Then it says the diagram shows parts of three regular polygons A, B, and C meeting at a point. Polygon B has n sides. Work out the value of n. So key word over here is regular polygons. So that means interior angles are equal for all of these. So we know when angles meet at a point, all of those angles add up to 360. So that means we can rewrite this as 7x plus 3x plus 8x equals to 360. That's 18x equal to 360, which is x equal to 360 divided by 18, and that's 20. Our focus is finding on the sides for polygon B. So interior angle of polygon B is going to be 7 times 20, which is 140 degrees. So we can use the formula for each interior angle, which is n minus 2 times 180 over n. So that's 140 equals to n minus 2 times 180 divided by n. Cross multiply 140n equals to 180n minus 360. Expanded the brackets. So 360 equals to 180n minus 140n, which is 40n. 360 divided by 40 is your value of n, which is 9. So polygon B has 9 sides. For these type of questions, you need to read your question very carefully. Actually, that applies to all questions, but you need to pick on keywords. Regular polygon means all of the interior angles are equal. And since angles were meeting at a point, so sum of angles would be 360. So using that, you find your value of x. Then you need to remember your interior angle formula, which is n minus 2 times 180 over n. Sum of interior angles is n minus 2 times 180. Then you do not divide by n. Other than that, you need to know your exterior angle formula, which is 360 divided by n. And for the number of sides, you can do 360 divided by exterior angle. So another way you could have done is that once you found the interior angle, which is 140, you could have subtracted that from 180, which gives us 40 degrees as well. And then you could have used that in the exterior angle formula, where n equals to 360 divided by each exterior angle. So 360 divided by 40 would have given you 9 as well. Once again, there's several ways to go about a question. You need to pick that method which is the easiest for you to understand and is less time consuming, because the goal is to save as much time as possible so that you can focus on the last 5 questions on the paper, which are the most difficult ones. Then it says f is inversely proportional to the square of v. Given that f equals to 6.5 when v equals to 4, find a formula for f in terms of v. So when it says inversely proportional, that means the equation is going to be f is inversely proportional to 1 over v squared, which means f is equal to k over v squared. In inverse proportion, k is divided by the other variable, whereas in direct proportion, k is being multiplied by the other variable. So let's say we're saying f is directly proportional to the square of v. So that would be f equals to k v squared. This is for direct proportion. So this is the basic distinction you need to remember. In inverse, you divide. In direct, you multiply. Also, another thing, an inverse proportion, your variables are going in opposite direction. So let's say if one variable is increasing, the other would be decreasing, and vice versa. Whereas in direct proportion, either both are increasing or both are decreasing. So going back to the question, they're saying that find a formula for f in terms of v. So first, we substitute these values to find the value of k. 6.5 equals to k over 4 square, 6.5 times 16, and that is going to give us 104 for k. So that means f equals to 104 over v square. That's it. Apart from that, they can also ask you to find, they will give you the value of f or v and ask you to find the value of the other thing. So that is the only thing they can ask you. Apart from that, there's nothing more to this topic. They only test you on these things. They ask you to create the formula, and then using the formula, they can ask you to find the value of one thing where the other thing is given. So main thing you need to remember is the distinction between inverse and direct proportion. In inverse, it's k divided by the other variable, whereas in direct, it's k times the other variable. And like I said, focus on the keywords in the question. Over it said square of v. Most kids would have ignored the square and just done f equals to k over v. The square is very important. If you don't put that, you're not going to score full marks. And these are easy marks, so we cannot mess this up. Then it says express 1 over 9x squared minus 25 minus 1 over 6x plus 10 as a single fraction in simplest form. So this is algebraic fractions. For algebraic fractions, they're mostly going to give you two fractions with different denominators, and they're asking you to turn it into a single fraction in its simplest form. So same thing over here. What we need to do is we first need to make the denominator same, because that's what we do when we're adding or subtracting fractions with unlike denominators. So the same rule applies to numbers, and the same rule applies to variables in a fraction. So that means we're going to times the first fraction by 6x plus 10, both the numerator and denominator. And the second fraction by 9x squared minus 25. Now that the denominators are same, we can write it as a single fraction. 9x squared minus 25 and 6x plus 10. 6x plus 10. Now this minus sign, it's going to get distributed with this thing. So it's going to become minus 9x squared plus 25. Do not make the mistake of just writing minus 9x squared minus 25. That's incorrect. This minus sign is in the middle of the two fractions. So when you combine the fraction, the minus sign gets distributed with both the terms on the second fraction. So it becomes minus 9x squared plus 25. So 6x is the same, minus 9x squared is the same, and what changes is 25 plus 10, which is 35. So this is what we have. Now, clearly, we need to factorize this quadratic equation to simplify it. But before we do that, I would like to factorize the 9x squared minus 25, which is difference of perfect squares. Difference of perfect squares is a rule where we're subtracting two perfect squares. So over here, x is being squared, 9 is 3 squared, and 25 is 5 squared. So we can rewrite that as 3x minus 5 times 3x plus 5, and 6x plus 10 comes as it is. So we just factorize 9x squared minus 25 using difference of perfect squares and rewrote it as 3x minus 5 times 3x plus 5. Now, let's factorize the quadratic equation over here. So for the quadratic equation in the numerator, 9 times 35 is 315. Now we need factors of 315. So that's going to be 21 times 15, because 21 minus 15 is going to give us 6, which is the middle term. So I'm going to write this over here in a different color. Negative 9x squared plus 6x plus 35 is going to be 9x squared plus 21x minus 15x plus 35. Factor by grouping. So in the first two terms, we have negative 3x common. So that's 3x minus 7. And the last two terms, we have negative 5 common. So that's going to be 3x minus 7 again. Between negative 3x and negative 5, we have 3x minus 7 common. So now we can replace the numerator with this. So that's 3x minus 7, minus sign outside because I'm taking that common from negative 3x minus 5, and that's 3x plus 5, and 3x minus 5, 3x plus 5, 6x plus 10. We can see that there's a 3x plus 5 in the numerator and denominator, so we cancel those out, and then we're just left with negative 3x minus 7 over 3x minus 5 times 6x plus 10. This is your simplified fraction, a single fraction. And, oh wait, we can further simplify this. We can take the 2 common from 6x plus 10. So let's rewrite that. Negative 3x minus 7 over 2 bracket 3x minus 5. And this is 3x plus 5. This is your fully simplified answer. Then it says the histogram shows information about the total time, m minutes, taken by each child in a school to walk to school every day for 1 week. So in a histogram, as you would know, we have the frequency density on the y-axis and the class intervals on the x-axis. Be very careful about this, even when they haven't given us the histogram and they're asking you to make it. You have to find the frequency density first. And in case you don't know the formula, frequency density has the formula of frequency over class width. FD stands for frequency density, CW stands for class width. So we divide the frequency by the class width to get the frequency density value for each interval. In this case, they have given us the histogram and they're saying there are no children for whom m is greater than 100. So there's nothing over here. And there are 10 children for whom m is less than equal to 20. So over here we have 10 children. So that's the frequency for this interval. Work out an estimate for the number of children for whom m is between 50 and 80. So basically, they want us to find this and then half of this. So let me divide that first. So if we divide this, 1, 2, 3, this graph is so tiny. Give it. 1, 2, 3, 4, 5. So let's draw a line over here first. This is 50 and they want us to estimate the number of children in this shaded area. Okay, so first let's begin with using this frequency value to find the frequency density. We know the class width over here is 20, which is the difference between the maximum and the minimum value of the bar. So frequency density for the first interval is going to be 10 over 20, which is 0.5. Which means this is 0.5. So that means this is 1, this is 2, 3, 4, and 5. So using just one value, we can easily find the scale for the frequency density. Once you've done that, what we do is we find the frequency density values for each of the other bars. So for the second bar, it's 3.2. This is 4.5. This is 2.9. Again, 3.2. Yep. And this is 2. So for the frequency for the bar from 50 to 60, we know that this is 50. So we multiply the class interval by the frequency density. Frequency density for this part is 2.9. As you can see, frequency density was frequency over class width. So frequency would be frequency density times class width. So that's 2.9 times 10, which is 29. Now for the second shaded bar, we can see that 80 is coming over here, by the way. So you missed out this shaded part. Now for this part, frequency is going to be, this is 75. So this is going to be 2 times 5, which is 10. And for this part, it's going to be 3.2 times 15, which is going to be 48. So total estimated children during this part is going to be 29 plus 10 plus 48, which is equal to 87. So for this, we need to be very careful about our interval. I almost overlooked this part. So this is also a part of our given range because I, for some reason, assumed that 80 was over here, but 80 is ahead of it. So this is the entire area that we're referring to. So for this first shaded part, we do 2.9 times 10. Why 2.9 times 10? Because it's from 50 to 60. So the interval is 10. So that's why we multiply 2.9 by 10. And then this over here, this is from 60 to 75. So that's 3.2 times 15. And for the last one, it's 75 to 80. So that's 2 times 5. We have the individual frequencies for the 3 bars. We add it up to get the estimate of the number of children within the given range. Then it says without using a calculator, show that 12 over root 2 minus 1 minus root 2 whole power 5 equals to 2 root 32 plus 12. So this question is for Surds. And over here, we are dealing with prime factorization also and rationalizing the Surd as well. Two different things. So what we will do first is we will rationalize the Surd, which is basically we're going to focus on the fraction 12 over root 2 minus 1. When we talk about rationalizing a Surd, basically what we're trying to do is we're trying to get rid of the Surd from the denominator and bring it in the numerator. So what we will do now is we will multiply the fraction by the conjugate of the denominator, which is going to be root 2 plus 1, and divide it as well. When we say conjugate, basically we mean the same expression in the denominator, but with the opposite sign in the middle. So if it's initially root 2 minus 1, like it's in the question, the conjugate would be root 2 plus 1. If it was root 2 plus 1, initially you would multiply and divide it by root 2 minus 1. So just remember, first step to rationalize the denominator is you multiplying and dividing the fraction by the same thing in the denominator but with opposite sign in the middle. If it was just 12 over root 2, then you would multiply and divide the fraction by root 2. That's it. But in this case, you don't just multiply it by root 2. You have to multiply and divide it by root 2 plus 1. So this comes as it is on the side. Let's keep it like this. So it's going to be 12 times root 2 plus 1 over root 2 minus 1 times root 2 plus 1 minus root 2 whole power 5. So that's 12 root 2 plus 12 over. Okay, now to save time, you need to remember that whenever we're multiplying a minus b times a plus b, it's basically a square minus b square, which is difference of perfect squares. So let me write this down over here. A minus b times a plus b is a square minus b square. Difference of perfect squares. So if we look at this, it's exactly the same as this, but a is root 2, b is 1. So instead of expanding it and wasting time on that, you can just simply rewrite this as root 2 squared minus 1 squared. Simple. And then this minus root 2 to the power 5 comes as it is. So that's going to give us 12 root 2 plus 12 over square of a root is the number itself. So it's going to be 2 minus 1, which is 1. So it's 12 root 2 plus 12 minus root 2 to the power of 5. Now, if you compare this with the original fraction, there is no surd in the denominator anymore, which is exactly what we were trying to achieve by rationalizing the denominator. So remove the surd from the denominator and bring it in the numerator. Now we have to show that it equals to 2 root 32 plus 12. So now if we notice this and this, we can see that we need to basically fix the surd. The 12 constant is as it is. So let me rewrite this root 2 as root of 32. Now, how did I come up with that? 2 to the power of 5 is 32. So if it's root of 2 whole power of 5, that's the same as root of 2 to the power of 5, which is the same as root of 32. So I'm just rewriting this in a different way. And over here, this 12 root 2, if we bring the 12 back into the surd, it's basically 144 times 2. Why? Because 144 is 12 square. And square root of 12 square is 12. And that's why 12 was outside. So if you bring it back into the surd, it's going to be as 12 square, which is 144. So 144 times 2 minus root 32. Now 144 is basically multiplied by 2, 288. We need to rewrite 288 as 32 so that we can combine the surds. So let's see, is 282 divisible by 32? Yes, it is. 288 is 32 times 9. So we can rewrite this as 12 plus 9 times 32 minus root 32. Just 12 plus. So now 9 can come outside as 3 because 9 is a square number and square root of 9 is 3. So 3 root 32 minus root 32, which is 12 plus 2 root 32, exactly what's given in the question. So like I said, in these type of questions, whenever you have a surd in the fraction, you have to rationalize the denominator. We've already discussed the methods for those. There are two types of fractions, one with just just a surd, like for example, 12 over root 2. Then you would multiply and divide the fraction by just root 2. But if it's 12 over root 2 minus 1, like in this case, then you multiply and divide the fraction by root 2 plus 1. And then over here, converting it into a format that's already given in the question. So then you just have to rewrite the surd in a way that's already mentioned in the answer, change it and convert it into the correct format, simplify it, and give your answer. We rewrote 12 root 2 as root of 288, then simplified it and gave it a number of 32 inside the surd so that we could combine it with the other root 32, simplify it, and give it in the same format as given in the question. So that's how you go about it. Then it says the diagram shows a sketch of part of the curve with equation y equals to f of x. There is one maximum point on this curve. The coordinates of this maximum point are st. Find in terms of s and t the coordinates of the maximum point on the curve with equation y equals to f of x minus 2. So for this, you need to remember your transformation of functions. If something is being directly added or subtracted to x, that means we're moving the graph horizontally. If something is being directly added or subtracted from f of x, that means you're moving the graph vertically. Now over here, it's f of x minus 2. If something is being directly subtracted from x, that means you move that many units to the right side. So ST means that when it's f of x minus 2, that means we're moving over here 2 units. So it's going to be s plus 2 for x. Y is going to be exactly the same. Why? Because the transformation is being done horizontally, not vertically. Then part B says y equals to 3 times f of x. 3 times f of x means that we're multiplying something directly to f of x, which is the y value. So that means the transformation is happening vertically, not horizontally. So now in this case, s would remain the same and t would be multiplied by 3. So the coordinates are going to be s and 3t. So key takeaway from this is that if the transformation is happening along the x-axis, if something is being subtracted from x, you move that many units to the right side. If something is being added to x, you move that many to the left side. Whereas for y, it's the opposite. If you're subtracting something from y, you move down that many units. And if something is being added to y, you move that many units up. And for the scale factor, if something is being multiplied to f of x, you multiply that with the y value. However, if something is being multiplied to x, let's say it was y equals to f of 3x, then you will divide x by 3. If it was y equals to f of x over 3, then you would multiply x by 3. So if you notice, the rules are opposite for x. For y, the rules are like, common sense. Plus something, you move up. Subtract something, you move down. Multiply something, the value increases. But for x, it's opposite. If you're subtracting something from x, you're moving to the right side. That means you're adding that value. If you're adding something to x, that means you move to the left side. You're subtracting that value. If you're multiplying something to x, that means you're actually dividing the x value by that. And if you're dividing x by something, that means you're actually multiplying x by that value. So remember these rules, because otherwise, if you apply the same rule for x and y, your answer would be incorrect for x. Then it says a solid is made from a cone and a hemisphere. The circular plane face of the hemisphere coincides with the circular base of the cone. The radius of the hemisphere and the radius of the circular base of the cone are both 20 centimeters. The curved surface area of the cone is 580 pi centimeter square. The volume of the solid is k pi centimeter cube. Work out the exact value of k. So for this, they've told us that the radius of the hemisphere and the circular base of the cone is exactly the same, which is 20. We have the curved surface area of the cone. So using the radius and the curved surface area, we can find the slant length. Let's begin with that first. So slant length has the formula of pi RL. So pi RL equals to 580 pi. Pi times 20 times L equals to 580 pi. The pi's get cancelled out. So L is going to be 580 divided by 20, which is going to be 29 centimeters. That's your slant length, this thing. Let me highlight that as well. This. Now they want us to find the volume of the solid, which is k pi centimeter cube. So they want the exact value of k, which means we cannot convert it into decimals. If there's going to be a root, we need to keep the root as it is, because exact means no decimals. So as we know, for the volume of a cone, we need the height. Whereas for the hemisphere, we already have the radius, which is 20. Volume of cone is 1 over 3 pi r square h. This is the formula. Height is basically this distance. So if you notice, we have a right angle triangle over here. And in this right angle triangle, we have the hypotenuse, we have the base, we need to find the height. So we can easily use Pythagoras to find the height. So 29 squared equals to 20 squared plus h squared. 29 squared minus 20 squared whole square root is h. (29 squared minus 20 squared). That gives us a value of 21. So volume of cone is going to be 1 over 3 times pi times 20 squared times 21, which is 3 ones are 3. This is 7. 2 squared is 400. So 400 times 7 times pi, that's 2800 pi. Volume of hemisphere is going to be 2 over 3 pi r cube. Why 2 over 3 pi r cube? Because sphere is 4 over 3 pi r cube. Half of that is 2 over 3 pi r cube. That's 2 over 3 pi times 20 cube. So 20 cube is 8,000. 8,000 times 2 is 16,000. So 16,000 pi over 3. So now total is going to be 16,000 over 3 pi plus 2,800,000. That gives us 24,400 over 3. Sorry, 2,800 pi. Since pi is already given over and they want us to find the value of k, so this is k, 24,400. Because 3 times 2,800 is 8,400, and 8,400 plus 16,000 is 24,400. So 24,400 divided by 3 is the value of k. Then it says the functions f and g are such that f of x equals to x squared minus 2x and g of x is x plus 3. So one is a quadratic function and the other is a linear function. The function h is such that h of x is f of gx, where x is greater than or equal to -2. Express the inverse function h inverse x in the form of h inverse x equals to this. So let's first find h of x, which is f of gx. So this is a composite function. F of gx means that we're substituting g of x in f of x. So wherever there is x in f of x, we replace it with g of x, which is x plus 3. So it's going to be x plus 3 whole square minus 2 times x plus 3. X plus 3 whole square is x squared plus 6x plus 9 minus 2x minus 6. Collect the like terms. So x squared plus 4x plus 3. This is your h of x, which is a quadratic function. Now we have to find the inverse of h of x. So to find the inverse of h of x, you need to remember that whenever we're dealing with quadratic functions and they're asking us to find the inverse of the quadratic function, we find the completing square form. So for the completing square form, what we're trying to do is we're trying to complete this square. If you know a quadratic equation exists as a square plus 2ab plus b square, which is the same as a plus b whole square. Right now, this is x square plus 4x, which is a square plus 2ab, but we don't know what b square is. And b square is needed to convert it into a complete square, which would be a plus b whole square. So using this, we will figure out what b is, because 4x equals to 2ab. And since x is a, so 4x divided by 2x equals to b, and that gives us 2. Which means we can rewrite this as x squared plus 4x plus 2 square, because that's b square. But then again, we'll also write minus 2 square along with plus 3. The reason why we wrote minus 2 square as well is because plus 2 square is a new term that we introduced in the equation. It did not exist before that. So since we're adding something new, we have to subtract that as well. It's the same as when we're, adding or subtracting fractions with unlike denominators. When we multiply something with the numerator, we multiply the same thing with the denominator as well. Because you can't just randomly multiply something with the numerator, especially because it didn't exist before. So keeping the exact same rule in mind, if we're adding something new in the equation, you're supposed to subtract it as well to maintain a balance. So since we did plus 2 square to complete the square, we will do minus 2 square as well. So now, since this is our complete square now, what we will do is we will rewrite this as x plus 2 squared. Just like a plus b whole square over here, a being x, b being 2. And this will come outside, minus 4 plus 3. So x plus 2 whole square minus 1. This is your h of x. Before I move on to finding the inverse of h of x use format, I would like to discuss one more thing. Whenever we're converting a quadratic equation into completing square form, your first step is to check whether the coefficient of x squared is 1 or more than that, or even less than that. In our case, it was 1, so that's why we easily started off with these steps. In the case it's not 1, let's say, our equation is f of x equals to 2x squared minus 3x, let's say. So your first step is going to be to take the coefficient of x squared common from the entire equation, which means it would be 2 bracket x squared minus 3 over 2x. Once you have taken it common, then you complete the square using this bracket. The 2 that you've taken common, that will remain outside throughout the process. You will, solve that right at the end of the equation once you've converted into completing square form. But completing square form can only begin once you've made the coefficient of x squared 1. If you haven't done that and you start solving from the beginning and, convert into completing square form, your answer will be incorrect. So please make sure that you have made the coefficient of x squared 1 by taking its coefficient common from the entire equation. I repeat, the entire equation, not just x squared. It's taken common from every single term given in the equation. Once you've done that, then you apply these steps on the bracket, and then at the end, you multiply 2 with the bracket and the other terms. So going back to this, h of x is x plus 2 whole square minus 1. The reason why we converted this into completing square form is because initially, if we look at our equation in this step, we had 2 x's. And when we're trying to find the inverse of an equation, we need to make sure that x is alone on one side. In this format, we cannot isolate x on one side. But in this format, as you can see, there's just one x, which means we can easily make it the subject. So the whole reason behind converting the quadratic equation into completing square form is to make sure that there's only one x in the equation. So that it's easier to make it the subject and write the inverse. So now we replace h of x with y. And right now, y is the subject of the equation, so we make x the subject. First, we add 1 over here. Then we're going to take the root on both sides. So that leaves us with plus minus root of y plus 1 equals to x plus 2. The reason why I attach plus minus with the root is because whenever we're taking the square root, we get a positive and a negative value. We move the positive 2 to the other side, it's going to be negative 2 plus minus root of y plus 1 equals to x. Replace x with h inverse of x and y with x. Now the question said that x is greater than equal to negative 2. Another important thing you need to know about is that if we're talking about the original function over here and the inverse function, whatever is the domain and range of the original function, that becomes the range of the inverse and domain of the inverse. So we swap them. Domain of the original will be range of the inverse, and range of the original would be the domain of the inverse. So since over here h of x exists for x greater than equal to negative 2, that means this was your domain. So now for the inverse, it's going to be your range. So it says x is greater than equal to negative 2, which means over here, our inverse would be negative 2 plus root of x plus 1, not minus. Why? Because if we do negative 2 minus root of x plus 1, we're decreasing the value of our function. It's going to be less than negative 2. We want it to be greater than equal to negative 2. And to make it greater than equal to negative 2, we need to add the root to negative 2, not subtract it. So for that exact reason, our answer is going to be negative 2 plus root of x plus 1. That is your equation for the inverse of this quadratic function. Question 30 says, Abraham is going to play a computer game. Abraham can win the game, draw the game, or lose the game. For any game that Abraham plays, the probability that he wins the game is 0.3. The probability that he draws the game is 0.5. The probability that he loses the game is 0.2. When Abraham wins the game, he scores plus 10 points. When he draws the game, he scores 0 points. And when he loses, he scores negative 5 points. Abraham plays 3 games, and the points he scores in each of the 3 games are added together to get his total score. Work out the probability that when he has played 3 games, his total score is 0 points. So looking at the scores, total score can be 0 if it's plus 10, minus 5, and minus 5. Or if it's 0, 0, 0. And for this, there are different possibilities. It can be negative 5, plus 10, negative 5, or negative 5, negative 5, and plus 10. For this, it's going to be the same. Apart from that, there's no other way of getting a 0 as the total points. So we know for the draw, the probability is 0.5. So for all draw, let me just color code that. Draw, draw, draw. This is a win, lose, lose. So 3 ways for that. So for draw, the probability is 0.5. So that's 0.5 times 0.5 times 0.5. Or win, lose, lose. So that's going to be 3 times 0.3 times 0.2 times 0.2, which gives us 0.125 and 0.3 times 0.2 squared times 3 is 0.036. Add the two. 0.161 is the probability of him scoring a 0 for his total score after playing 3 games. This diagram shows two circles with center O and a regular pentagon ABCD. Keyword over here, regular pentagon. Two circles and there's a center O. A, B, C, D, and E are points on the larger circle. The pentagon has the side length of 8 centimeters. The diagram is shaded such that the shaded area is equal to the unshaded area. We have to work out the radius of the smaller circle, giving your answer correct to 3 significant figures. Okay, so if it's a regular pentagon, number of sides are 5. So if we split this into 5 identical triangles, we know that the angle for full circle is 360. So if we do 360 divided by 5, that equals to 72. So all of these angles are 72, all of them. Yeah. Once again, it's a regular pentagon. That means these lengths are also going to be equal. So we can find these angles as well. So for angle OBC, that's 180 minus 72 divided by 2. That's 54. So that's 54. And it's going to be the same for all of them. So let me color code that. These are all the same. Okay. So to find the shaded area, if you look at one sector, let me just make that separately over here. B, O, C. And then we have this over here like this. And then we have another circle over here. We have this as 54. These lengths are equal, which are the radius of the bigger circle and radius of the sector. We know that this is 72. So what I'm thinking is that if we find, also let me highlight the shaded region as well. They have given us the pentagon sides, they're 8. So we can write that as well. This is 8. If you notice, we can find the radius because if you look at the triangle OBC, we have the length of BC, we have the angle, and OB and OC are equal because they're the radius. So you can use the cosine rule because for the cosine rule, we need 2 lengths and the angle between them. You can actually use the sine rule as well. Let's go for sine rule because we haven't used sine rule in this predicted paper so far. So we're going to do 8 over sine of 72 equals to r over sine of 54. Yeah, let's do that. So let's find the radius of the bigger circle first. Let me write that. R is radius of big circle. So 8 sine 54 divided by sine 72, that's 6.81 centimeters. Okay, we have the radius now. We need to find the radius of the small circle. Okay, since we have the radius, we can figure out the shaded and unshaded area now. If we find the area of the circle, the big circle, and then subtract the area of the pentagon from that, we can find the shaded area that's outside. Yeah. So area of big circle, that's pi r square. So that's pi times 6.81 square. 145.69 centimeter square. Then we do area of pentagon. So for the area of pentagon, what I'm going to do is I'm going to find the area of one triangle and times it by 5 because there are 5 identical triangles. So 5 times 1 over 2 times AB sine C. We're going to use that formula because we have 2 lengths in the angle between them. So 5 times 1 over 2 times 6.81 squared sine of 72. So 6.81 squared times sine of 72 times 5 divided by 2. That's 110.26 centimeters square. So shaded area 1 is going to be 145.69 minus 110.26, and that gives us 35.43 centimeters square. So we have the area of this part, the outside shaded part. Now for the inside shaded part, we need to find the area of the smaller circle, and for that we need the radius. However, we can use the concept that shaded area equals to unshaded area. So we can create an equation where shaded area is area of small circle plus 35.43 equals to 110.26 minus area of small circle. Yeah. We're going to use this equation to figure out the radius of the small circle. So that's pi capital R square. Capital R is the radius of small circle plus 35.43 equals to 110.26 minus pi capital R square. Combine the like terms on both sides. So capital R square plus capital pi R square, sorry, is 110.26 minus 35.43. That's 2 pi R square. And we do 110.26 minus 35.43. That's 74.83. So R square is going to be 74.83 divided by 2 pi. And then we take the square root on both sides. So 74.83 divided by 2 pi. And then we take the square root of that, and that's 3.45 centimeters. That is the radius of the small circle. Then it says that the curve C has equation y equals to x cubed plus bx squared minus 12x plus 6, where a and b are constants. The point A with coordinates 2, -6 lies on C. The gradient of the curve at A is 16. Find the y coordinate of the point on the curve where the x coordinate is 3. In case you're someone who doesn't know when to use differentiation, first sign for using differentiation is that they've given you a curve and they're talking about gradient. If there's an equation for a curve and they're asking you to find the gradient, or they've given you the gradient, that means that differentiation will be used in that question. Because if it's a linear equation, we don't need to differentiate to find the gradient. We can easily convert it into y equals to mx plus c form and identify the gradient. So curve and the word gradient in the same question, differentiation is coming over there. Then apart from that, if it says find the maximum value of something, and again, there's like a polynomial where the highest degree of power for x is more than 1. Again, differentiation. Then if like we're talking about rate of change with the curve, differentiation. If we're talking about turning points of a curve, differentiation. Nature of roots for a curve, again, differentiation. If they're talking about displacement, velocity, and acceleration, like for example, they gave displacement and they're asking for velocity, differentiation, because if you differentiate displacement, that gives velocity. If you differentiate velocity, that gives acceleration. So you need to look at keywords in the case that you don't know when to use differentiation, when to use sine rule, cosine rule, the interior angle, stuff like that. Things that are not evident in the question, you need to highlight the keywords to make yourself understand what they're asking for and which method that you need and which method would be best suitable for you to use in that question. So over here, like I said, we have a curve. The gradient of the curve at A is 16. They gave us the coordinates for point A, and they want us to find the y coordinate where the x coordinate is 3. So let's begin with finding the value of A and B, because without that, we cannot find the value of y for x equals to 3. So if y is ax cubed plus bx squared minus 12x plus 6, dy by dx is going to be 3ax squared plus 2bx minus 12. In differentiation, what we do is we bring the power of x down, multiply it with the coefficient of x, and then subtract 1 from the power. So as you can see, I brought the 3 down, and then I subtracted 1 from 3, so that gave me 2. So it became 3ax squared. Similarly, I brought the 2 down, so it became 2b, and then power of x is 2, so 2 minus 1 is 1. Same thing over here, power of x is 1, so 1 times 12 is 12, and 1 minus 1 is 0. Anything to the power of 0 is 1, so the x disappears. And for a constant, the derivative will always be 0. So that's why we don't write anything for 6. Now it's said that the gradient of the curve at A is 16. So that means at x equals to 2, because for point A, the x coordinate is 2, dy by dx is 16. So that means 16 equals to 3a times 2 square plus 2b times 2 minus 12. 16 equals to 12a plus 4b minus 12. 16 plus 12 equals to 12a plus 4b, which is 28 equals to 12a plus 4b. All three terms can be divided by 4, so that's going to be 7 equals to 3a plus b. This is just my attempt on simplifying the equation. Now, this is the first equation. And as you can see, we have two variables in this, which means we need to create another equation and solve that equation simultaneously with this one to find the value of a and b. We know that point A lies on the curve C. So what if we put that into the curve equation and create another equation in terms of A and B? So that's going to be -6 equals to A times 2 cubed plus B times 2 squared minus 12 times 2 plus 6. -6 equals to 8A plus 4B minus 24 plus 6. 8A plus 4B minus 18. So then -6 plus 18 equals to 8A plus 4B, which is 12 equals to 8A plus 4B, which can once again be simplified to 3 equals to 2A plus B, which is our second equation. Now let's solve them simultaneously to find the value of A and B. So 7 equals to 3A plus B and 3 equals to 2A plus B. I'm going to use elimination method and eliminate B because B has the same coefficient in both the equations. So we subtract the 2 because both B's are positive. So to get rid of the B, we need to subtract them. 7 minus 3 equals to 3A minus 2A and B minus B is 0. So that's 4 equals to A. Put A equals to 4 into either of the equations. I'm going to pick the second one. 3 equals to 2 times 4 plus B. 3 equals to 8 plus B. 3 minus 8 is B, and that's -5. Now that we have the value of A and B, we can plug it in the curve equation, substitute the value of x, which is 3, and find the y coordinate. So y is going to equal to 4 times 3 cubed plus -5 times 3 squared minus 12 times 3 plus 6. That is going to give us a value of 33. So the y coordinate is 33 when x is 3. The next question says that ABCD is a kite, AB equals to AD, CB equals to CD. The point B has the coordinates K1, where K is a negative constant. The point D has the coordinates 8, 7. The straight line L passes through the points B and D. The straight line L is parallel to the line with the equation 5y minus 3x equals to 6. Find an equation of AC, giving answer in the form of px plus qy equals to r, where p, q, and r are integers. Show your working clearly. So this is a question for coordinate geometry, where we talk about the line of equations, gradient, parallel lines, perpendicular lines, and so on. So we have a kite. So let's draw a rough sketch over here. This is what kites look like. And they're saying A, B, C, D. AB is equal to AD, CB is equal to CD. Your diagonal AC is perpendicular to diagonal DB. That is always the case in a kite because, as you can see, it's being divided equally. The length of AB is equal to AD, which means AC is acting as a line of symmetry. Similarly, BC is also equal to DC. So this is the right angle over here. You have the coordinates of B as K1, where K is negative. You have the coordinates of D, which is 8, 7. We know that straight line L passes through the points B, D. and straight L is parallel to this. Okay. So you need to remember that when two lines are parallel, gradient of line 1 and the gradient of line 2 is going to be equal. So let's convert this into slope-intercept form to identify the gradient of this line. 5y minus 3x equals to 6. Let's move 3x to the other side. So it's going to be 3x plus 6. Then divide both sides by 5. So we're left with y equals to 3 over 5x plus 6 over 5. This thing over here is your gradient. So m equals to 3 over 5. Remember, the coefficient of x is always the gradient. The constant is the y-intercept. Since the straight line L, which is passing through B and D, is parallel to 5y minus 3x equals to 6, so that means it also has the gradient of 3 over 5. Now, if this line has the gradient of 3 over 5, we can find the gradient of AC. As I said, they are perpendicular, so that means M1 times M2 would be equal to -1 in this case. That is the condition for perpendicular lines. So gradient of dB times the gradient of AC equals to -1. So 3 over 5 times gradient of AC is -1. So gradient of AC is -5 over 3. So we have the gradient sorted out. Now we know L is passing through the points B and D. If we look at the diagram, we can see that the line AC is bisecting the line DB. Bisecting means that it's dividing into two equal parts because we have two congruent triangles on each side. So which means the line AC is passing through the midpoint of BD. So if you find the value of the midpoint of BD somehow, we can use that to create the equation of the line AC. But to do that, first we need to find the value of K for point B. That can be done using the equation of the line BD. Now, how do we create the equation of the line BD? We know that the gradient of the line BD is 3 or 5. We know that D has the coordinates of 8, 7. So using point slope form, which is y minus y1 equals to m times x minus x1, we can find the equation of the line L, which passes through the point B and D. So y1 is going to be 7, m is 3 over 5, and x1 is 8. Cross multiply 5 times y minus 7 equals to 3x minus 24. Expand the bracket. So 5y minus 35 equals to 3x minus 24. 5y equals to 3x minus 24 plus 35, which is 3x plus 11. Now this is your equation of line L. So since line L is passing through the point B and D, we can substitute the coordinates K and 1 in this to find the value of K. So y is going to be 1, K is going to be x. So 5 minus 11 equals to 3K. Negative 6 divided by 3 is K. And K is equal to -2. And that was also mentioned in the question that K is going to be a negative constant. So we meet that condition. We have the value of K, which is -2. So -2 and 1 are the coordinates of B. Now that we have the coordinates of B, we can use that to find the midpoint of BD and then further use that to find our equation for AC. So B is -2, 1. So midpoint of BD, that's going to be 8 minus 2. x1 plus x2 over 2, comma y1 plus y2 over 2. 8 minus 2 is 6. 6 over 2 is 3. This is going to be 4. So now this is our point that lies on the line AC, and this is our gradient. So using these two, we will find the equation of AC. Y minus 4 times negative 5 over 3 times x minus 3. Once again, point slope form, because you have a point and you have a slope. Cross multiply 3y minus 12 equals to negative 5x plus 15. Expand the brackets. So 3y plus 5x equals to 15 plus 12. 3y plus 5x equals to 15 plus 12 is 27. They wanted the equation in px plus qy equals to r format. So this is your final answer. Then question 34 says the sum of the first 80 terms of arithmetic series S is 470. The 75th term of S is 14.5. The sum of the first x terms of S is 171. Work out the value of x. So we don't have the first term. We don't have the common difference. We just know that the sum of the first 80 terms is 470. The 75th term is 14.5. So the first x terms is 171, and we need to find the value of x. So what we're going to do is going to use this and this to create two different equations in terms of a and d, and then use that to find their values, and then further use that to find the value of x. So sum of n terms is Sn equals to n over 2 times 2a plus n minus 1 times d. SAT equals to 80 over 2 times 2a plus 80 minus 1 times d, which is 470 equals to 40 times 2a plus 79d. 470 equals to 80a plus 79 times 40, that's 3160d. All of them can be divided by 10, so that's 47 equals to 8a plus 316d. Okay. This is our first equation in terms of a and d. Now let's create the second equation. So the nth term formula is a plus n minus 1 times d. The 75th term is 14.5 equals to a plus 75 minus 1 times d. So that's 14.5 equals to a plus 74d. This is our second equation. So now we solve these two simultaneously to find the value of a and d. So 47 equals to 8a plus 316d. 14.5 equals to a plus 74d. I'm going to use elimination method to solve this, and I'm going to begin with eliminating a. So to eliminate a, we need to make the coefficients of a equal. And to do that, I'm going to times the second equation by 8. So 14.5 times 8 is 116, 8a, and then 74 times 8 is 592. Let me highlight the two equations that we're going to solve simultaneously now. So this is going to be, since a is positive in both the equations, so we'll subtract the two equations. So 47 minus 116 8a minus 8a is 0. 316b minus, there's a d over here, 592d. So 47 minus 116 is negative 69. 316 minus 592 is negative 276d. Divide the two, and that's going to give us 0.25 or 1 over 4. That's your value of the common difference. Now, using this value, we're going to find our first term. 116 equals to 8a plus 592 times 0.25. 116 equals to 8a plus is 148. 116 minus 148 divided by 8 is going to be a negative 4. A is negative 4, D is 0.25. Now they want us to find the value of x where x is some of the first x terms of s, which is 170. So sx equals to x over 2 times 2 times negative 4 plus x minus 1 times 0.25. So sum of the first x terms is 171 equals to x over 2 times negative 8 plus 0.25x minus 0.25. Multiply the 2 with 171. So that's going to give us 342 equals to x times negative 8 minus 0.25 is negative 8.25 plus 0.25x. Multiply the x with the bracket. So that's going to be negative 8.25x plus 0.25x squared. So 0 equals to 0.25x squared minus 8.25x minus 342. Now we have to solve this quadratic equation to find the value of x. So let's use the quadratic formula. X equals to minus negative 8.25 plus minus negative 8.25 squared minus 4 times 0.25 times negative 342 over 2 times 0.25. So that's 8.25 over here plus minus. Let's find out it's going to be 20.25 over here. And this is going to be 0.5. So since x cannot be negative, so we're going to only use x equals to 8.25 plus 20.25 over 0.5. That gives us x as 57. That is your final answer. Okay, last question. Vector. So the diagram shows triangle OAB, where vector OA is 8a. So let's highlight that. OB is 6b. M is the point on OB such that OM is to MB is 1:2. So that means OM is going to be 1/3 of 6b, which is 2b. And this will be 4b. MB is going to be 4b. N is the midpoint of AB. P is the point of intersection of ON and AM. Use a vector method, find OP as a simplified expression in terms of A and B. Show you're working clearly. So first, let's find AB, just AO plus OB. So AO is going to be in the opposite direction, so negative 8A, and OB is 6B. So if N is the midpoint of AB, so AN is going to be negative 8A plus 6B over 2, which is negative 4A plus 3B. Negative 4A plus 3B. And this is also negative 4A plus 3B. AN is the same as NB. P is the point of intersection of ON and AM. So we can find AM first. AM is going to be AO plus OM, which is negative 8A plus 2B. That's AM. And we can also find ON. ON is going to be OA plus AN. So that's 8A plus negative 8A plus 6B over 2, which is 8A minus 4A plus 3B. That's 4A plus 3B. Now we know OP lies on ON and AM. So we can begin with saying that OP is some scale factor times ON, and MP is some scale factor R times AM. Okay. Now MP can be rewritten as OP minus OM. So OP would be MP plus OM. So if we move to the next page, first equation we will create is OP is K times 4A plus 3B. So OP is equal to 4KA plus 3KB. That is our first equation for OP. Now over here, MP equals to R times AM, and MP is OP minus OM. So if we rewrite this as OP minus OM equals to R times AM. So OP equals to R times AM plus OM. So that's R times AM is negative 8A plus 2B, and OM is 2B. So negative 8RA plus 2RB plus 2B. Since OP is going to be the same, so we put both the equations equal to each other. So 4KA plus 3KB. I'm going to highlight this as well. Equals to negative 8RA plus 2RB plus 2B. So since they're both the same, so coefficients of A are going to equal to each other. So if we color code this is going to equal to this, and this is going to equal to this. So 4K equals to negative 8R, K equals to negative 2R, and 3K equals to 2R plus 2. So replace K with negative 2R to find the value of r. So that's negative 6r equals to 2r plus 2. That's negative 8r equals to 2. And r equals to negative 1 over 4. So if we use this, k would be negative 2 times negative 1 over 4, which is 1 over 2. That's k. So OP is 4 times 1 over 2a plus 3 times 1 over 2b, which is 2a plus 3 over 2b. That is your vector OP. So if you have any questions regarding any of the questions, leave a comment below. And I hope this video serves as a very good revision pack for you before the exam and helps you ace your exam. So best of luck to everyone who are going to pay for an exam on the 15th. And do share in the comment below once you're done with the exam, and do let me know how the exam was. Was the questions very hard? Were they very easy? Which questions were the most difficult ones? Which were the easier ones? Which topics came and which didn't? Looking forward to hearing back from you guys. So best of luck.